Hey, today I wanted to talk about something I tried to come up with a clever name for it. I'm calling it fluid architecture. I like to be able to stream this and record at the same time so that it feels like a little bit more natural for me to talk about, and then I don't feel like I'm rehearsing it and it's really contrived. But I did try to make some notes ahead of time, so I have a bit of a template to follow. So I'm just going to I have this open office little slideshow here. It's nothing fancy, but just has some notes that I want to go through. So when I talk about fluid architecture, what I mean is being able to develop software in a way that it allows you to essentially keep evolving what you're working on without having to necessarily stop everything you're doing. Spend a lot of time trying to redesign everything without delivering until, say, like months, potentially years, depending on what it looks like, and then sort of saying, okay, like here's the new hotness, or doing a complete rewrite. So kind of canning everything you have going on again, not delivering incrementally and then saying, okay, like here's the new thing we've created. So fluid architecture is sort of the opposite of that, where you're able to keep evolving without your system totally, sorry, not totally being compromised, and you can keep delivering things as you're going. So that's what I mean by fluid architecture. So I kind of want to get into, like, why this is something I feel that you should consider. Um, I wanted to also, I don't think it's really fair, like, to talk about, here's a way to look at stuff and like here's all the benefits of it without addressing any sort of drawbacks. I think that anytime someone's going to, propose something to you, you should be able to hear the flip side of it, right? If everything always sounds like, oh, here's all the perfect reasons why you should do something, then everyone would be doing it without asking questions. But if there's anyone that's going to question it, you should really be um, thinking like, well, there's got to be some sort of drawback. So what are they? So I'm going to get into sort of the pros, and then we'll follow up with the cons, and then I have some notes on, and I want to give some examples about how you go about this, and like I said, some examples that I've done in my experience. So we'll get started with the pros. So the first one, I've kind of hinted at it, but like business continuity, I think is a huge one. So if you're working in software teams, I'm going to try to give some context to like software teams versus like your own personal projects. So business continuity, I think, is important. If you're actually working in a software team where you are delivering software, there are customers that are using it, and there's a business to support. I think that if you have like every software organization is going to be a little bit different in terms of how this works, but so say in like an agile software shop, you might have product owners that are kind of the ones that will be telling the engineering teams, like, here's where we want to be spending time. So that could be a project manager in some cases, that might be a product manager. Like the titles and things might be different, but uh, if it does boil down to someone being able to make that decision, I think that when you're able to talk about having fluid architecture, you likely will have an easier time getting someone to give you and the team the ability to work on that kind of stuff. So if you were to say, like, look, we're not going to be able to ship software for 6 months, but when we do, it will be great. Versus like, maybe it's going to take us 7 months or 8 months to get it to closer to, like, to say almost perfect. It's like the ideal state. It's going to take us a little bit longer. But the cool thing is we don't need everyone's time, and we can still deliver other value as we're going. In my opinion and my experience, sort of that latter case is a little bit easier of a pitch to them, um, because when it comes down to business, if you're not able to continue shipping software, generally that's a big problem. I have another note here saying like a from scratch rewrite. So if you're taking something and you're like, well, it's going to be a bunch of work to make this better, um, so let's just scrap the whole thing and rewrite it. Either doing that or having a very long running refactor. And what I mean by a long running refactor is kind of from the previous example of like essentially waiting months before you can actually deliver value. It's kind of gating other value from being delivered. Um, from my experience, those are very expensive, and some reasons why are, um, you have potentially an entire software team held up trying to like as time is going on and you're like, say you're doing your sprints again in like an agile software shop, um, you're not actually introducing any more net new value to the customer. So you're sort of, it's like you're paying off this tech debt, and there's nothing wrong with that. But you're paying it off, and like from a customer's perspective, they don't care. They don't have insight into your tech debt. It's not something they should ever have to think about, because they're buying your software for the features and the functionality, right? So um, if it's like, well, sorry, you can't get updates, or you can't get new features or bug fixes just because we want to take time to redo this, like that's going to cost you, versus the alternative, like I'm explaining with fluid architecture, being able to say like, look, maybe we're delivering features and bug fixes at a slightly slower rate, and maybe it takes us a little bit longer to get to our ideal state, but you don't have this huge expense of not delivering software as you're going. um, so that's sort of the first major pro, I would say. Next one is, and I've talked about this in previous videos, sort of, and you might have heard the concept already, but this 80/20 rule. So essentially, software is never going to be perfect anyway. Um, so if someone's looking at a code base and they're like, you know what, we're not happy with this, maybe some parts are brittle, maybe it's not designed the way we want, and you sit back and you say, well, let's sit back and design, the perfect system, the perfect solution for this. The reality is, it's never going to be perfect anyway. There's two, like almost in any real situation, there's so many variables that you have to consider that, if you want to sit back and try to make something perfect, by the time you actually get into making it and actually have people using it and you're getting feedback on it, it's going to have changed anyway. Even if you've already built something like this in the past, as you get into things, there's going to be changes that come up. So um, the sub points I have here are just saying essentially like software is something that evolves naturally. So instead of pretending like it's not and trying to come up with something perfect, and then when you find out it's not perfect, saying, well, we have to scrap the whole thing, or we have to do a whole rewrite, or we have to spend all this time without delivering anything just so we can refactor. I think like you're setting yourself up for failure. Like you should be assuming that it is going to evolve, and then planning for that. um, it's like planning for the unforeseen things, so being flexible and nimble. The word agile is obviously, it's in my opinion overused a lot in software, so I try to avoid saying it, but you really want to be agile and nimble in the sense that you can let your software keep evolving as new things come up. Second point there, just saying like, as you keep repeating things, you're going to see new patterns come up. You or people on your team or people you talk to, new patterns are going to arise. We're going to say, oh man, like that is better. Like if we started doing this, that would actually stop us as developers from coding something that might be brittle or hard to test, or you know uh, is the cause of these certain types of bugs. So you're going to say, well, let's start introducing this new pattern to prevent that. um, it's just going to happen naturally, right? So if when that happens, you say, well, we have to stop everything so we can go change every occurrence of this pattern to the new one, you're basically hitting the brakes for all of your software, um, say within this team that's doing this, and then you're not delivering value as it's happening. So the other part is just obviously like, as you're working with customers, assuming that you have a feedback loop and you are taking customer feedback and trying to evolve software to suit customer needs, there's going to be new things that come up, right? So you can do all the research you want ahead of time with product teams trying to figure out all the features they want. But if again, this is a lot of it's based on my experience. The more conversations you have like that, that's great. But the more that people start to use actual software that you produce, the more they're going to say like, oh, you know what, like maybe I was wrong about that. Actually, this way is totally fine. Or what you did exactly what I said, and it's not really, now that I'm using it, it's not actually what I want. So like, their requirements and their needs are going to evolve over time. So yeah, in my opinion, if you have something like fluid architecture, you can support business continuity, which I think is very important when you actually have a software business, to keep delivering value to customers. And it's sort of the second part is just really accepting that software has to evolve over time. It's just not perfect, no matter how much planning you put into it. So just accepting that. So little, just a side note on like it. So if you're not working in a say a software team or a business and it's a hobby project, or um, your business continuity isn't a huge deal. I'll give you a personal example of something um, where I feel like I wish I would have done this for myself in my own hobby project. So one of the things that I've liked to do, just sort of to practice programming, that might be a really nerdy thing to say, but I actually really enjoy programming. And one of the things that I love to use to practice is actually making role playing game engines. I'm really bad with graphics, so I never focus on that. I like making the systems in the back end. So say like item generation and how your characters can progress and all that kind of stuff. Really love doing it. Um, However, what I had always done, and I mean when I say always, I mean for I'm trying like how old am I now? So like over a decade, probably, um, maybe like 15 years of this without exaggerating, where I would take start something that's a role playing game engine, start building it maybe over a year and a bit, and then get far enough in where I'm like, oh, you know what? Maybe I made some bad assumptions about this. Oh no, I've kind of reached a roadblock here for kind of extending this engine. Well, let me just restart it. I've learned a bunch. Let me just redo it. And what ends up happening is like I basically spend, I'll make up a number, but like say like 80% of my time just redoing everything I've already done. And then like I get about like a little bit further and then I reach this same type of roadblock. So I spend so much of my time repeating the same thing. And in my opinion, and where I've tried to get to, even like I'm saying in my personal projects, is when you reach that point where you're like, man, I feel like this design has kind of reached its maximum, its limits. We can't extend it anymore. Um, Instead of just giving up on it, it might be a good opportunity to start looking at the parts that do feel really good, making sure that you can kind of keep those isolated, and then start focusing on the parts that you don't like. So I'm going to come back to that at the very end for how to address it. I just wanted to share that I do feel like this can be applicable in your own personal projects, but the weight of these might, you know, business continuity. Maybe you don't care. I never had to ship my role playing game engine to anyone. It was just something for fun for me. So this first point for business continuity, did that really matter? No. It just kind of sucked to spend like years on something and not actually get much further every time. So great learning, but anyway. So let's talk about maybe the cons of this. And these are things that like I've picked up from other people over time when I have this conversation. And for me, they don't carry as much weight, which is why I do still talk about, why I think fluid architecture is a great thing. However, I think that they are important to talk about. I think they're important to understand, and then coming up with ways around them. Um, so the why nots. So cognitive load. This is something I've heard come up in the past. For me personally, I've worked in smaller software teams, so um, this is less of an issue. However, this concept of like, so say you have a bunch of people working in a code base, I think it's if you've been programming for a while, you probably notice that if you're in a code base and you're about to add a new feature into something or fix a bug, whatever it happens to be, generally programmers um, like to look at other existing patterns and examples so they can say, oh, that's how we do it. Okay, like I'll apply that in this particular case. Um, so when you start to have fluid architecture, one of the things that I like proposing is that when you start to introduce a new pattern, you don't necessarily go back and fix all of the old examples of it and sort of balloon the amount of time it takes. You just start introducing the new pattern. So when I talk about cognitive load here, I mean that the bigger the team is and the more complex the software is, and the more examples of these patterns that you want to be updating, the more cognitive load is there is, the more cognitive load there is. There we go. For people to understand what the new pattern is, what the new hotness is, um, so that they don't start accidentally reintroducing the old patterns that people didn't like. So hopefully that makes sense. But yeah, essentially it's just, you know, the more complexity there is, the more cognitive load there is for trying to keep up to date on all the new patterns that you want to be introducing in your architecture. So related to that, again, based on complexity of your code base and your team size and things like that, there is a load for communication. And I just made a note here for reviews. So same type of thing, but I'll give you an example. So say that you have a new member of the team. Maybe it's a co-op student. Maybe it's just a more junior developer that's come in. Maybe it's a seasoned person in the company that's just switched teams to work in your code area, and essentially they are tasked with fixing a bug, or they're adding a new feature, and they do kind of what I just said of like they're going to go copy an existing pattern because they're like, oh, that's how this team does it. Cool, like I can totally do that for them, and they feel good about it, and then they go put it up for review, and then, I mean, if they put it up for review and however that works. So let's take the example where they've added the new feature and it gets landed, and then later on, so say like a week later, 2 weeks later, someone goes, hey, wait, like, why are we doing it this way? I thought we said that we were following this new pattern. Essentially, if you're not keeping up to date on your communication and catching this kind of stuff in reviews, you start interleaving more of the old pattern back in with the new pattern, and it takes longer and it's harder for this new pattern to sort of take over your code base. Um, so there, in my opinion, there's certainly more load on. So say people coming into the team and working on stuff, they should be asking questions early about, like, someone asking someone else on the team, like, this is the way we do it, right? This makes sense. When people start introducing new patterns and saying, like, this is, we've talked as a group, this is the architecture we want to follow, this is the pattern we want to follow, communicating that out with people, right? um, I think having frequent open communication is really important on software teams. And maybe you want to have patterns that you can put into your code to make sure that this is tracked. So maybe it's for example, in C sharp, you can put like an obsolete tag on stuff. So maybe you can say, like, don't look at this example. You can leave a comment sort of as you're going, so that um, maybe it's not time for you to, it doesn't make sense for you to actually go replace one of the old patterns, but you come across one, you can leave a little comment just saying, by the way, don't use this. Little things like that you can decide as a team. But the point is that um, having a more fluid architecture certainly does add more load to communication, and what it might look like for your reviews to make sure that you can catch this kind of stuff, and continue the new good pattern that you want to use. So and then the last one, I just have a note here saying too far gone. So on the previous slide, I talked about the situation where I was saying, rewrite, bad thing to do. It's going to be costly. But I don't like having saying like absolutes, like you should never rewrite software. Um, because the reality might be that when we're talking about fluid architecture here, you're already dealing with a code base you've inherited that, I'll just make up a contrived example. Maybe there was something in place from a couple of years ago, hasn't really been touched, and someone was like, hey, like, we had this thing, it sounds like it does what you want, so you start revitalizing and resurrecting this project, turning it into a product. And as you're going through it, you're like, you know what, this is pretty far off base. Maybe it is worth asking the question: is a rewrite worth it? Right? Like, there is a balance between your business continuity. If it's not already being shipped, maybe it's worth taking the time up front and addressing, like, this is too far off the path that we want. Let's take the time to redo it. I just think it's worth asking the question. Um, Generally, from again from my experience, depending on how out of date something is, a lot of the time there are great methods for basically starting to introduce a fluid architecture and progress something and refactor as you go. However, I don't want to pretend like there's never a situation where you should consider a rewrite. So I just wanted to mention it because I don't think it's fair to not say it. Okay, so those are some of the cons I've come up with. I've mentioned some of the pros. I'm not saying these are the only things to consider, but these are some of the major ones I've had come up in conversation, the ones that I think are important. I'm sure after I finish recording this, I'll go, oh, like I should have talked about something else. But that's part of the reason why I like to do this live, so that uh, it feels more natural for me to just talk about it, and maybe I'll make another follow up video or something on it later. So we've talked about pros, we talked about cons. What about like how do we do this? If we want to start incorporating a fluid architecture into our systems, what do we do? So I have a couple notes here. I've talked about some of these things in different videos. So I wanted to elaborate on them and then maybe give some concrete examples if I can, either from personal experience in my hobby projects or generalized experience from my career. So I like being able to give some examples from real life in like software industry so that there's more weight attached to it. Obviously, I need to omit specific details on things so that I'm not sharing private stuff. But anyway, I think first one, abstractions and flexibility. I made a video before on sort of software pillars. I've talked about trying to decouple things with interfaces and abstractions. But I think one of the core things here is when you're designing software, trying to decouple concrete implementations from each other, I think is really important. So the example I like to give is it's a really simple one, probably overused, but like something like a data layer. You know that your software wants to be able to persist data to some type of storage, right? You might have picked like a MySQL database, maybe it's a SQLite database, whatever it happens to be. Um, but abstracting that away so that the developers calling that API that say like, I just want to save information, I want to persist this, they don't know that it's MySQL. They don't know that it's SQLite unless they're like right into those libraries. If they don't know, then they don't make assumptions about certain things and then sort of like scatter that through your code base. Because the more scattered those dependencies start to get, the more coupling you have across your code base, and then it becomes significantly harder to have a fluid architecture. Um, so that's, I think, one of the most critical parts of this is really just trying to decouple things as you're designing stuff. If you have systems that are already coupled, um, that's not the end of the world. I wouldn't say, oh no, things are coupled, time to throw it all away. There's definitely strategies you can take to start decoupling as you're going. Again, my opinion on that is by decoupling as you're going, that's starting to introduce a fluid architecture, right? Taking some small steps to start saying, you know what, we're calling this concrete class here on this specific implementation. Let's wrap this in an interface. Let's put this behind an API. So the next person to come in here can start building on this. Then we can share as a team, hey, you're fixing bugs in this area, no problem. If you see this type of thing, just start introducing this new API that we're using, right? Like you start introducing things as you go, without saying everyone hit the brakes, let's go back, no one can develop anything else until we go address this. Like you can just do it as you're going, and I think that's really critical. Next part, functional tests. I mentioned this one because a lot of what I like to talk about when it comes to testing, just by from my again my experience as a programmer, love writing unit tests because for me it gives me confidence over like the granular steps in my lines of code, in my classes, my methods. So when there is a problem, I know exactly where it is. However, as you're starting to refactor things, um, you're like a unit test that's testing specific lines of code being executed become very coupled. It's one of the things we just talked about not doing, but they become very coupled to your implementation. For a unit test, in my opinion, that's totally cool because the point is that you're proving it does exactly what you say. And I think it's important to mix in things like functional tests that don't care about that. And the reason why is if you only had unit tests and you start to refactor these systems, because your unit tests become very coupled to the implementation, you have to change all the unit tests, right? Because you've changed the implementation, have to change the unit test. Cool. Um, but does it still work? Right? And I think if you have something like functional tests that can cover larger parts of this system, um, then you can say, you know what, we changed the implementation. This functional test still says that it's doing, like a black box. It's still doing what it says it should. We don't know what's happening on the inside from the perspective of the functional test, but it looks like it's doing what it should. It has the behavior we expect, so it passes. I think it's important to mix these two things together. I think if you're only going to have one type of test, a functional test, it's the way to go. It'll cover coded functional tests. Will cover like more of what you want. I do think that if you can design stuff to have the ability to be unit tested, then that's great too, because then you have really granular coverage over things. But that's why functional tests I think are important for this, for your fluid architecture. Um, I've talked about it already for like in the pros, but like you definitely want to look at things as like a bite size or piecemeal part of what you're doing. So when you're thinking about a fluid architecture and you're like, you know what, how we've been, interfacing with our database, we all of our spots in the code are they know that it's a MySQL database. I'm just making this up, but like we're already talking about like switching over to um, a certain type of NoSQL database, um, and we have all this logic scattered. So instead of saying I've already talked about this in different ways, but instead of saying everyone stop, like we can't land any more code until we go address this and put this behind a new API or whatever it happens to be. Um, Instead of doing that, just start saying, okay, the new pieces we're adding, we're putting behind this API. I think it's a really good sell to your product owners. It lets you keep making progress and delivering value. And I think it's just in general good practice for agile software development to be able to have these small incremental deliverables. I think a lot of the time, some people um, they think about software deliverables as being like things that users can see. Um, and this might be different in different software shops. I've seen this different in the same software shop, but across different teams. But having this perspective of like um, we have a user story, so the user should be able to see it. So if I'm going to add value in, like we should have someone maybe like a tester or another programmer that can see or the product owner, we can demo it to them and they can see the end result. I think sure, that's one way to look at it, but I do think that there's absolutely space in agile software development to say like we're delivering functionality and call it a story. Maybe it's not a user story because the user won't see it, or you have to change who the user is to, I don't know, like sometimes I feel like the agile stuff is really contrived. But anyway, being able to deliver a small piece of functionality, covering it with tests, having someone review it and saying like, this code will do what we expect. I think it's a great way to start delivering smaller bits of value, again without pausing everything. And then just the last part, I talked because I want to be able to address some of the cons here. Communicate and review. I think it's critical. It's less important if your team is like one person. So if it's just you working on stuff, great. Um, you don't really have to communicate with anyone. You're probably not doing a code review, a formal code review for yourself. But as soon as you have one other person on the team, um, I think it's really important that you start talking about, hey, like this is the pattern we want to start doing. I've noticed, I'm going to keep using the database example. I've noticed that we keep addressing the the storage mechanism is explicitly MySQL. Maybe that's not a good practice. So going forward, we should do this. Then on the reviews, trying to call that kind of stuff out, looking for it. And then the flip side too is like when you're starting some work, like you're picking up a new story on your team, the sprint's just started, and you're getting into it. Instead of just putting your head down and being like, oh, I know everything about the code base, I'm just going to blindly start coding. Take a couple minutes and just message a colleague. Like if everyone's working remotely, it's you're not just turning to a colleague. You shoot them a message on Slack or whatever. Maybe call them up and just be like, look, I'm about to do this, I just want to make sure this is the right pattern we said we are going to adopt. And then get into it, right? Catching it early before it gets to the review, I think, is super helpful. It saves people time. So um, I wanted to give a couple of concrete examples. First one I'm going to give, and why I wanted to put this video together, is something that recently happened. I'm going to see if I can switch over the stream here to show Visual Studio. Not that one. Oh, it might be gone. Okay, well, one sec. Again, this is the nature of doing stuff live. Let me get some code up. There we go. Okay, so when I was working through this application I'm making with a couple of friends, we basically reached a point where we said, cool, like things are mostly functional. Um, and then we started talking about some of the UI designs, and we started questioning some things we were doing. And this is kind of what I was getting at in my slides, where I'm saying like things are going to evolve. So we came up with some paradigms that kind of challenge what we were doing before. And instead of me throwing away the whole app and going, well, it's good that we learned this, let me start it from scratch, what I started doing was porting things over to a new format. So the thing I wanted to call out here was um, I have a bad habit of doing this to start, and it's just literally from years of doing it, trying to break out of it. But I generally make architectures and layers, and almost always get to a point where I'm like, the layers don't make sense anymore. So the pattern I had before was that I would, if I wanted to put a new screen in, I would put I'm already digging into multiple folders here. I would go, so I'm going to pick on this friends page. I would go add this view. So this is in Xamarin, so I'd have a WPF control. And then I would go have a interface for it, an interface. So again, another folder over here. And then I would go into the view models, and I would go into this friends folder, and then I put all the view model stuff in, and I might have a controller for it. So there's a friends controller, and you can, as I'm clicking through this, you're I don't know, like you might already be like, why is this scattered everywhere? Um, so what I started to do is, as we were revamping um, the UI for some of these new paradigms, was I said, you know what, like I'm sick of jumping around all these folders. Every time I want to make a new screen, it has these similar components. So I started migrating stuff into a screens folder. So we have a login screen, and it has the view pieces, and right beside it, it has the view model pieces. Um, I have a common navigation thing that I generally use for these different screens. There's a controller for it, and then the nice thing is there's an autofac folder that has a module for doing all the dependency injection. So the really cool thing is this layout lets me have like one folder that contains everything I need for doing login stuff. So it's a nice little sort of package of login. Like it's really convenient. So my point with this and why this relates to this whole topic is that I was able to start porting the screens over to this paradigm, and I still interleaved. I have these other pages and stuff still mixed in. So I have both the old way, where I have pages with their interfaces, scattered with these view models over here, with a controllers folder over here. I still have that paradigm in the code base, but I've started introducing this new one, and I'm doing that fluidly. So every time I go to update one of these pages, I port it over to the screen folder and convert it. So I just do it as I go. Um, so when I started doing that, I was like, hey, this might be a good thing to talk about in a video. I've seen this come up literally, you know, in professional environments where it's like, well, we feel that we can't go ahead and make this change because we can't have these things coexist. And I just wanted to be able to talk about why I think you can. Another example from my professional experience is, I think, a pretty cool one. So this example I just walked through here is a little bit more of like a organizational sort of core code organization. Whereas this other one I want to talk about was actually a technology choice. So um, the application we were building at the time, we started building out in WinForms, and we were like rapidly putting this application together. And it was really awesome. We were able to use all the technology that we were used to using, part of what the organization was using already, um, iterating fast, and had something functional within no time. And then what ended up happening was towards the end of that, we started hearing, well, we think that we want to start, like as an organization, start shifting to WPF because WinForms is getting a little dated. WPF is sort of like, um, it's going to be replacing it, a lot more support, looks way better, like, so there's a lot of really good reasons to shift to it. And we were kind of like, well, that sucks, like we just build all this stuff in WinForms, like what are we going to do? So we came up with a pattern that essentially allowed us to start interleaving. We were building new screens, we could start interleaving WPF with WinForms, and then every time we had to go back to a screen or we got a little bit of time that from our PO, we could say like, we want to add another story to the sprint. Just let us go back and update this page from WinForms to WPF. And there's no issue at all. And we were able to start, all the new screens being added were WPF. All the old ones that we had to go refactor because of bugs or new features and stuff, we would just port them to the new format. And I think a really cool thing about that I want to share is like, I think I think it took about, and it might, to this day, it might not be true, but I think it took about 4 years for us to actually replace the final WinForm screen. And I say that might not be true because there still might be WinForms in there. And the reason I think that's important is because if we would have taken um, all of the time to go replace all of it without continuously delivering and having like a fluid architecture, I'm pretty confident that that product would not have ended up where it is. We maybe would have missed the mark on a window of opportunity for shipping to customers, getting their feedback. So in my opinion, I think it was critical that we had a way that we could fluidly keep adapting the architecture. Um, so yeah, I wanted to share that one because it's a real example of something we did. How we did it, that's a different story. But the point is that we decided, like, when you're talking about software engineering, there's always constraints, right? So one of the constraints we imposed was that we can't stop shipping the software, right? We made that a constraint. Once that's a constraint, and we said we can't stop shipping the software, and the other constraint is all the new stuff has to be WPF, great. Like we play within those boundaries. From there, we come up with creative solutions for making that true. Um, so I think that when people say, well, it can't be done, it's like, well, you're just looking at the wrong constraints. Like if that is truly a constraint that you have to keep shipping software, get creative, right? That's part of our job as software engineers. So I think that's about it. Just wanted to touch on pros and cons of doing fluid architecture. Again, I think it's critical in software engineering organizations that you're able to do that. Obviously, the technology choice, how you're shipping to customers, and things like that will have an impact on and sort of the age of your software will have an impact on your ability to do that. I think it's something that's important to think about, though. Um, and yeah, again, I don't think that it is free. Like, there's obviously trade offs to doing it, things like communication and cognitive load. But I do think that the benefits almost always outweigh the drawbacks here. So thanks for watching, and hopefully that helped in some way.